Welcome to the next part on our lecture series on astronomical history. In this part, I'm going to discuss a little bit about the two different types of planets, inferior and superior, and then I'm going to give you a way of figuring out the different configurations Earth makes with these types of planets. So let's start by discussing inferior versus superior planets. So inferior or inner planets, these planets are, when we say inferior, we don't mean like dumb or bad or of lesser quality. Actually, my favorite planet is an inferior planet. We just mean planets whose orbit is smaller than Earth's orbit. So when you think about the order of the planets from the sun outward, you have Mercury, Venus, and then you have Earth, and then Mars, Jupiter, Saturn, Uranus, and Neptune. So Mercury and Venus are before Earth in that order. Those are our inferior planets. So we have Mercury. And I'm writing these out like this because I also want to draw the symbol that goes with them, and I want to leave enough space. So Mercury has a symbol that looks a bit like the female symbol, but it also has these little horns sticking out. And then we have Venus. Incidentally, those horns are supposed to represent like the wing cap of Mercury, the messenger of the gods. In Roman mythology, Venus just has this female looking symbol. And those are our two inferior planets. Incidentally, Mercury is my favorite planet, if you were wondering. I doubt that you were, but in case you were, it's Mercury. The superior planets, or outer planets. The superior planets are just planets with a bigger orbit than Earth's. And here we have all of the rest. So we have, starting inward and moving outward, we have Mars. And Mars has the male symbol as its planetary symbol. You don't need to memorize these symbols, by the way, but I'm going to be using them throughout the course. So it's good to recognize them, but you don't need them for like an exam. I'm not going to ask, which symbol is which or anything like that. So after Mars comes Jupiter. And Jupiter's symbol looks a bit like a 4 or a 21. Then we have Saturn. And Saturn's symbol looks like an H with a crossbar on it. That crossbar is too long. It's actually supposed to be pretty short, like that. Then we have Uranus. And Uranus's symbol is kind of weird. So it's a circle with like a stick coming out of it and then an H on top of that stick. And then we have Neptune. And Neptune's symbol is a trident, which I think is just excellent. Okay, so these are our planets. The inner planets are Mercury and Venus. The outer planets are Mars, Jupiter, Saturn, Uranus, and Neptune. What we're going to do here is we're going to talk a bit about different configurations that these planets find themselves in, and we're going to start with the superior planets. So the superior planets are outside of Earth's orbit, and because of that, they move slower than Earth. So I'm going to draw a couple of cartoons here before we actually get to the meat and potatoes of what I want to do. But if we have like two planets that are starting next to each other, Earth actually moves faster. So as these things time evolve, so as you like push play on the movie, this outer planet will have moved a little bit and Earth will have moved a lot. So by the time this outer planet, gets wherever it's getting to, Earth will have moved quite a bit. So say Earth completes the orbit here, and that outer planet is now there. So Earth moves a lot faster than this outer planet. And that's important because when we draw this next diagram that we're going to draw, and this is one of those diagrams you need to know for exam 1, it may show up. We're going to take it from the view of Earth. So instead of drawing both of these moving around, we're just going to draw Earth in one place. And we're going to assume Earth doesn't move. And that's going to mean that this planet is going to be drawn like this. So this is 1. This here is the same as this here. So that's 2. Then they're opposite each other. So that's this one over here, 3. And then finally Earth whips around and they've made another right angle, 4. So even though both of these planets are traveling counterclockwise as seen from north, from the point of view of Earth, it looks like that outer planet is actually moving clockwise. Okay, so let's go ahead and get rid of all of this and do the actual drawing. So we're going to start with, we're going to assume circular orbits for this, but you do not need them to be perfect circles in order for this to work out. So we're going to do 2 circular orbits. And we're going to go ahead and roughly cut this circle in quarters. So maybe that could go down a little bit, and that one looks fine. All right, then we're going to draw another circle. So this first circle that we've drawn, that's the orbit of some planet, say Mars. And then we have the Earth, which needs to have a smaller orbit. And so like I said, we're going to take the Earth-centric view here. So I'm going to go ahead and draw the planet Earth, just hanging out over here. Oops, that's not what I meant to do. I'm going to draw the planet Earth just hanging out over here. And then we have the sun, of course, in the middle. So we're going to draw the sun maybe using yellow. That's probably a good color for the sun. So we've got the sun in the middle. And then we're going to draw the planet Mars in a couple of different key locations. So we're going to go ahead and draw this planet in those locations that I indicated earlier. So from Earth, they're directly opposite or in line with Earth, and then 90 degrees with respect to that opposite in line. So we're going to draw Mars appearing here, appearing here, appearing way over here, and appearing over here. Perfect. So, like I said, we're taking this from the perspective of Earth. So we're going to label that 1, 2, 3, and 4. Just like the moon, it's actually going to be important what side of Earth is morning and what side of Earth is evening. So we're going to go ahead and take the northern hemisphere view from this, and we're going to assume the planets are moving counterclockwise and Earth is spinning counterclockwise. So that means that this portion of the Earth is covered in shadow, and this portion of the Earth over here is covered in sunlight. So what that means is that as we turn from day into night, it is sunset over here. And as it turns from night into day, on this side, that makes it sunrise. Perfect. So we've got sunset on top, sunrise on bottom. All right, now we're going to draw how Mars is being illuminated by the sun. So the sun's rays are moving directly from the sun toward the planet Mars. So we're going to go ahead and just draw one sun ray moving from the sun to Mars. And it's going to illuminate the half of Mars that is being exposed to sunlight. So this half of Mars is being illuminated, and the other half is being cast in shadow. So from Earth, we ask, well, what does Earth see? And Earth, if it's looking at Mars, will see the entire face of the planet Mars. The entire thing will be lit up. So just like the moon, we're going to do something similar here. We're going to label these 1, 2, 3, and 4. And we're going to ask what the phase looks like. So the phase of Mars in this case is going to be fully illuminated. So it looks full. All right, so next we can talk a little bit about 2. So 2 is a little bit tricky, but here's how it works. So we have a ray coming from the sun toward 2. So the part of 2 that is being illuminated is the part that's directly in sunlight. So it's this half. And that means that the other half is directly facing away from sunlight and is in shadow. What does this look like from Earth, you might ask? Well, from Earth, we take a look from this direction. And from Earth, we'll see that this actually looks mostly full with a tiny sliver of shadow. So this is just like we saw with the moon. This is a gibbous phase. So there's a slight shadow on the left, and the rest of it is illuminated. So we call this gibbous. Two has a pretty important name. So in going from day to night, this planet is visible in the evening at sunset. So at sunset, the sun is on the horizon, and this planet is going to be directly on the meridian. The sun rises in the east and sets in the west. So if you're looking at this planet at sunset and the sun is on the western horizon, this planet appears to be east of the sun. So position 2 is known as eastern quadrature. So eastern because the planet appears to be east of the sun, and quadrature is just a fancy word that means like square. And the reason it's square is because this angle here between the sun and the planet is a right angle. So eastern quadrature, eastern because it appears to be east of the sun, quadrature because it is at a right angle to the sun. All right. Up next, we're going to describe position 3. And position 3 is kind of interesting. So if you were doing this based on the moon, you might expect that there would be a full phase, a crescent phase, a half phase, a gibbous phase, and a new phase. But check out what happens at 3. At 3, Mars is being illuminated. And the entire face of Mars that is being illuminated is also the face of Mars, the side of Mars rather, that's facing Earth. So take a look at where Earth is here. If we look along the direction of Earth, and oops, that is not the right color. If we look along the direction from Earth here, we're actually facing the part that's fully illuminated. So instead of going from full to some gibbous phase and maybe a couple crescents in there to a new phase, we actually go from full to gibbous back to full. There's something weird happening here, and it has to do with the fact that the sun can never shine on the planet in a way that we see the planet from the back. Because the planet is outside of Earth's orbit, it's always going to either appear full or gibbous. You're never even going to have it half illuminated. That's not something that you can see from Earth here. So there's actually a special name for 1 and 3. So when a planet appears on the opposite side of the sky as the sun, so the sun is on one side of the sky and the planet is directly opposite. So the sun is setting and the planet is rising, or the sun is rising and the planet is setting. So direct opposites. That is called opposition. And when they are very close to each other in the sky, like the closest they'll get on the sky. So if you're looking from Earth, the sun and the planet are both sort of in line with each other, right? So we're looking from Earth, there's the sun, and we keep looking and there's the planet. So in the sky, those will be in the exact same location, basically. That is what is known as conjunction. Conjunction just means together. So they appear together on the sky. Right now, actually, by the time you watch this, will probably be the opposition of Jupiter. So by the time you watch this, if you go out at sunset, you'll see the sun sinking down on the western horizon. And we're in summer, so it'll sink down a little bit north of west. Think about the seasons, think about why that's true. And you'll actually see Jupiter rising at about the same time. So the last one here is our last phase that we're interested in is another quadrature phase. And this time it's Western quadrature. And you can probably already guess what's going to happen here. So the planet is illuminated by the sunlight. And part of it is in shadow. And as seen from Earth, oops, let's do that a little bit lower maybe, perfect. And again, this is going to be one of those things where like our view is rotated because we're upside down. So just the exact same sort of idea that we had with the moon. So here the dark spot is going to appear on the right instead of the left, and it's another gibbous. So it's mostly full with a tiny bit of shadow. And this time that shadow is going to appear on the right instead of the left. Like this. So here we have Western quadrature. This will have the planet directly on the meridian at sunrise. So because the sun rises in the east, this planet appears west of the sun. So Western quadrature. And again, this is going to be a gibbous. The takeaway here, and there's a couple of them, is that superior planets only allow full and gibbous phases. And the other takeaway here is that your planets are going to be in opposition when they are directly opposite the sun, and conjunction when they are on the exact same side as the sun. So opposition is the opposite side of Earth compared to the sun. And conjunction is the other definition we need here, which is on the same side of Earth as the sun. I should probably capitalize sun. Great. So that's it for this first diagram. Make sure that you can draw this and make sure you can label the correct locations and what the phases look like at those locations. In the next part, we're going to deal with the inferior planets. So these are the superior planets. And when we do those, it's going to look slightly different. You'll see. All right. So I'll see you all in the next section. Take care till then.